Hey guys, this is Ojas here, welcoming you to one more video. So let me start this video by saying that there are two problems on LeetCode which are very similar. In this video, we're going to talk about one of the problem. So even though these two problems are similar, the final code would be a little bit different, obviously because of the problem statement, but I would highly encourage you guys to solve these problems together, or at least one after the other. And by doing that, you guys would have absolute understanding of the underlying data structure, which is same in both these problems. Now you guys would ask me that if the problems are similar, why am I doing separate videos? Well, the YouTube pretty much heavily works on YouTube title and description, and for that reason I'm just doing two separate videos so that it's easily searchable. But I'll make sure that the thumbnails of both the problems are very much similar, so when you guys browse the channel, you guys can point that these two problems are similar. So enough of this preamble, let's look at the problem and let's start the video. So in this video, we'll take a look at a problem which is related to Trie data structure. Now, Trie data structure is quite a unique data structure in a way that it's not commonly used, like especially in colleges and courses, we come across data structures like stack, linked list, queue, array, and we don't come across Trie much. So that's one point. And then other is if we are interviewing for companies like FANG and all that, then they expect us to know the Trie data structures. So that's why it's kind of special or kind of different from other data structures. And if you're interested in knowing what are the real world usage of Trie, then applications like autocomplete or spell checker or few kind of word games, they really like Trie data structures and they really use that. So having said that, today we'll be looking at problem implement Trie or prefix tree problem. So basically in this problem, they're asking us to implement a class Trie which has three methods: insert word, search word, and starts with prefix. So basically the idea is when they call insert word on our class, we need to store the word such that later on when they call search or starts with method, we need to return true or false respectively. So let's quickly take a look at the example. Now in this example, they're inserting the word apple, and then when they search the word apple, we should return true. But if they search for just app, we would return false, saying that just app doesn't exist, but there's apple. So, and then when starts with app calls in, we obviously return true because apple starts with app. And then later on when they call insert again with the word app, and then they say search app, we would return true because now we have the word app also. So what we'll do is we'll look at the Trie class design, and while we are looking at this Trie class, we'll look at some of the variation of this class which can help us solve other few problems in future. So let's go to the whiteboard, let's look at the design of the Trie class, and let's see how we can solve this problem. So a typical Trie definition or class would have children array. So that'll be like in case of lowercase characters, we'll have 26 characters. So we'll have a children array of 26, and then we'll have a marker to say that this is the end of the word kind of thing. So in this case, we have a boolean. Now remember that there can be variations of this class. So the basic idea would remain same, but let's say that if we have to have more characters, as in like lowercase characters, uppercase characters, or numbers, or all those things, then instead of this Trie array of 26 children, we can have a map which will have key as character and then value as the Trie data structure. So that's one variation. Now in our current problem, our search method requires us to return true. Now imagine a case where search method requires us to return a word or the list of words that match the search. So in that case, instead of this end of word marker, we'll have the string word itself at the end. So when we reach to the end of the word, we say that yes, this is the word that we matched, and then from search method we can return that word. So that's another variation of try. And in fact, there is a problem on LeetCode which deals with finding XOR of all the numbers in array, and that uses try data structure. And in that case, the children array size will be 2 because it will be holding 1 and 0. But anyways, that problem is for some other day. Right now we'll just deal with this word problem. So now we'll actually see how our try class performs when we start pushing words into it. So we'll take words like mad, mat, Mars, bad, and dad, and then we'll see how our try spans out when we add those words one by one. So let's start with the word mad first. So before anything, what we do is we have our root object, which is obviously of type try. Now it has 26 children, so 0 to 25. And now we'll take the first letter in the word mad. So what we'll do is all of them are null, and we'll go to this letter M, which is 13th character in A to Z. So we'll initialize this 13th child in the array, and we'll create a new try object at that instance. By default, our end of word is false, so we'll just keep as is. Now this will denote that we have a word with letter M in our try. Now we'll move on to this new try object that we just created, the children of this root object, 13 children. And in this try object, which itself will have 26 children, will denote the letter A over here by creating new try object at 0th position. So that'll denote that there's a letter A. And again, end of word will be false because we are at letter A. Now in this A letter, or in this try object, will denote letter D by creating new try object at 4th position. So that'll denote that there's a letter D. So rest all the children in the arrays are null except M, A, and D over here. And in this last try object, all the children would be null. The only thing we'll do is we'll mark end of word as true. So that'll denote that this is the end of the word mad. So if we come here while searching, return true and say that we found the word. So that's how our try will look like if we add word mad. Okay, so now into this root object, or into this try data structure, we'll try to add second word, which is mat. So now we start with root and we say that, okay, go to this 13 children, which is M, and if it's empty, then create a new object, otherwise just use that. So because we added mad, there is already a try object. So from root, we just navigate to this try object. Now because we already have A, we'll just navigate to this try object instead of creating a new one. So we are repeating M and A because mad and mat, they both have M and A. So we'll keep them same. Now into this third try object, which is the children, we already had D and we created a new try object and we marked end of word true. Similarly for T, we'll create a new try object and we'll mark end of word true. So for D and T, we have new try object with end of word as true, and remaining all the children are null. So that's how we'll say that, okay, this try data structure has mad and mat. So when we search for those, we'll return true. So just like this, let's quickly add the remaining words, which are Mars, bad, and dad, and see how our complete try data structure looks like. Okay, so this is how complete try data structure will look like. So let's look at the Mars part first. So just like mad and mat, we already have M, so we'll just navigate to that try object. Again, we see A, we already have that try object, so we'll navigate to this. And now we already have a D and T, so we'll create a new object for R. Now we'll navigate to that new object try, and we'll create another new object for S. So this will again be a new try object, and now over here we'll mark end of word as true because that's the end of Mars. Now likewise for bad and dad, we'll go to the root object, we'll create new object for B for bad, we'll go to the try object, we'll again create a new try object for A, we'll go to that. We'll again create a new object for D, and for that try object, we'll mark end of word as true. And similarly for dad, we'll create a new try object for D, A, D, and then we'll mark end of word as true. So this is how we add words into try data structure. So now let's quickly write the code for this add word method, and then we'll come back and look at the search part of it. Okay, so this is our try class. We have array of 26, and then we have boolean variable to mark end of word. So in this insert method, we start with the current object, which is this, and then we iterate that current object over each letter. So we'll loop through each letter in the word, and then we'll look in the children array if that character has already a try object. If it's null, then we'll create a new try object, and then we'll mark our current to that character. So we'll keep looping to next character, and then once we finish looping through all the characters and creating try objects, for the final current object, we'll mark end of word as true, which will denote that this is the end of word. If we reach here in the search method, then return true. So that's all about add word. Now that we know how try works and how we push words into it, we'll look at search method. And since we have already built the data structure, it's pretty easy to search in that data structure. But let's see how it works and then come back and finish the code for that also. Okay, so now with hard part of building try data structure done, we simply need to search into it. So this is the easier part. So let's see how we'll do that. So for example, let's see if we have to search mad into this try data structure. So we'll start with the root. We'll look at the 13 children, which is M. Is it initialized? Yes. So we'll go to that object. We'll look at letter A, which is 0th object. Has it been initialized? Yes. So we go to that object. Now we look at the 4th object in the children, which is D. Has it been initialized? Yes. So now after coming to this try, since our letters are done, we look at the end of word property. Is it true? Yes, that's true. And then we return true from our search method, saying that yes, mad is there in this try data structure. So let's look at a negative test case where the word doesn't exist. Let's search man in this try. So similarly, we'll start with root. We'll look at M, it exists. So we'll go to that try. Now A, it exists. We'll go to this try. And now over here, we'll try to look at N, if the try object or if that children has try object. Now we'll notice that it's null. So since that is null, we say that N doesn't exist, and we return false from our search method, saying that man doesn't exist. So that's how the negative search or the false will return. So this is how we search in our try data structure. So let's go back, finish the search method, and then submit and then run the code. Okay guys, so this is the search method. Now similar to insert method, we'll start with current variable, which is marked to this, and then we'll loop through each character in the word, and we'll keep moving our current variable to the next children in that array. So if you think of our example mad, we'll start with the root, and then we'll move to M, we'll move to A, we'll move to D, and then our characters would be done. And then at the end, we would come to this current dot end of word. If it's true, we'll return true. If it's false, return false. So that'll be the happy path. And just in case, while looking for the character, we come to a try data structure which says, hey, in this children array, I don't have this character, then our current would become null, and we would return false from that, saying that, hey, this word doesn't exist. So that's how search works. Now, similar to search, let's look at startsWith method. Now, in this one also, we start with the current variable, which is marked to this. And for each character, we keep moving our current variable to that next children or to that next character. So the difference between search and starts with is in this return statement. If we finish all the characters and if we don't hit current equal to null, then we will return true because we're searching for starts with. As long as we are hitting the characters, we are good because we can say that yes, there are words starting with these prefix. So we'll return true. The only case we'll return false is when we run out of character or when our current starts pointing to null. And that's when we'll say, hey, there's no word in this try class which can match this prefix, and we'll return false. And let's make sure that we pass all the test cases. So there you go, we pass all the test cases with this code. So this is Java code. I also have C# code. Both the version of code are readily available for you guys. The link is there in the description box. You guys can go to the GitHub link and then take this code and run it. So that's it, guys. I hope you guys understood how trie data structure works and you guys can use it in different various applications. So if you guys liked the video, give me a big thumbs up and subscribe to the channel. It really helps me out. And if you have any feedback, any suggestion, positive, negative, anything, just let me know in the comments box. I'll try to respond. And that's it, guys. Keep on practicing, keep on coding, and I'll see you in next one.